Hello and welcome to Season 2, Episode 13 of LogiCast. If you're superstitious, you might be wondering why we're having an Episode 13. Unlucky for some, we could have skipped to 14. And of course, I'm a Manxman, so we are very superstitious by nature. So maybe I should have done that. But I've also got OCD, and having a gap in the episode list probably would not have sat very well for me. So anyway, welcome to Season 2, Episode 13 of LogiCast. And this is not a pure monologue from me. I'm joined as always by my colleague John, who's chomping at the bit to say something. So how are you doing today, John?
Well, for starters, it's champing. You don't chomp at the bit, you champ at the bit.
Oh,
it's champing.
Okay. Yeah.
For second, you're going to have to explain to those that aren't familiar what a Manxman is. Like, most people know what a Geordie is, but maybe not a Manxman.
Well, I'm sure our listeners are very well educated and would know the difference between a Manxman and a Mank. So a Manxman is a person from the Isle of Man, which is a little island in the Irish Sea between England and Ireland. And a Mank, of course, is somebody from Manchester. Gets confusing because when you have more than one person from Manchester, they are called Manx, but that's spelled M-A-N-C-S, whereas Manx, as from the Isle of Man, is spelled M-A-N-X. So it sounds exactly the same, but two completely different things, referring to different people from different parts of the world, albeit not that far apart, but separated by a piece of ocean. So, There we are.
There's no funny name for where I live. I'm just from the south of England. There's no, I mean, there's some fairly nasty names if you watch films from the 90s, like Lock, Stock and Two Smoking Barrels. Soft southern large swear word, but there's nothing cute about being.
Maybe we should come up with one. Could you be a burger from Burgess Hill? Because the first thought was Burgess Hillian, but it's a bit of a mouthful. So
I mean, the football team is called the Hillians, admittedly,
Okay,
but that's just
yeah. It's not quite as catchy as Manx or Mank.
No.
There we go. Anyway, we're not here to talk about regional nicknames. As you'll know, if you're regular on the podcast, we're here to talk about AWS news. Once a week, I curate a list of AWS news, which I share via my weekly AWS News Roundup newsletter. And then John and I pick a subset of those articles that we'd like to dig into in a little bit more detail on the podcast. So we've got such a selection of articles this week. And the first one, you might have noticed, John, that this passed my vendor filter. So I'm usually pretty strict on not including promotional content from third-party vendors. Although I did actually read this article and I thought actually it is a relatively unbiased point of view. So it does appear on the Sysdig blog, and obviously Sysdig, I'm sure, have an ulterior motive for writing this article, but it doesn't heavily promote their products and services. I thought it was a fairly neutral view on Terraform security best practices. So we're a Terraform house. John's day job regularly involves writing Terraform. So I thought this would be a good one for us to start. So John, what can you tell us about these Terraform security best practices in this Sysdig article?
I just find it funny that you've introduced us as AWS news and then we've spoken about something that isn't that.
That's true, but it's in the ecosystem.
It's cloud. It's cloud.
It's cloud, and obviously it is vendor neutral, but definitely works very well with AWS.
Yeah. All right. So this is an incredibly long article. As you say, it passed the filter, but there's a little bit of a pitch for TerraScan, which I think is a Sysdig tool. So we're just going to kind of gloss over that. In terms of Terraform and risks of using Terraform, it's kind of the same risks of using pretty much anything else that you run from your local desktop, right? It's things like leaving credentials where you shouldn't be, and it's things like opening ports that you shouldn't because you haven't sort of understood what you're doing with it. So Terraform is kind of not unique in that regard. There are tools to help scan your Terraform code to work out whether you've done something silly. TerraScan, Checkov, KICS, those sorts of things, which they kind of mention in the article. And I think TerraScan is the Sysdig tool. But if you scroll down past that, there's some really sort of good tips and some good points. It's don't store secrets in your Terraform state if you can help it, because your Terraform state is unencrypted. It's just a text file. You should encrypt where you're storing it, but it's unencrypted. So don't store secrets there if you can really avoid it. Don't put secrets in plain text. We should all know this, but if we don't do that. Really don't. Things like, usernames, passwords, and whatever. Don't pass them in as plain text. And if you're creating, say, an AWS database, have rather than passing in a variable, what you could do, it says here, you could sort of pass it in as an environment variable rather than coding it in. What I tend to do is I'll tend to actually create the thing in the Terraform itself using a random provider. So it creates a random string and then stores that in a SSM variable and then uses that. And then we obfuscate because I say that it's secret. So it kind of blocks it in the state file. So that's kind of another way of doing it. Anything else in there that's interesting? Yeah, rotating keys frequently. This is not specific to Terraform. It's anything that has a key. I think the CIS benchmark is make sure that your keys for anything are rotated, depending on what they are, every 90 days to every 1 year, depending on what they are. Like your CMKs you can do annually, but your access keys that you're using should be every 90 days. So that's definitely worth doing. Terraform or no. Least privilege, again, worth doing. Terraform or no. You can, in fact, have Terraform permissions as well. So, only allow apply and plan, but not destroy, and things with the state and so on and so on. So again, least privilege. Don't trust third-party code that you don't understand. So in here, it talks about Terraform modules. There's this massive range of modules in Terraform, community modules that have been kind of semi-reviewed, but not necessarily. The community modules have been relatively well reviewed, but anyone or their mum could publish something on GitHub that you could find. So don't use it if you don't understand what it's doing. Don't just blindly use them. Always run a plan, because Terraform will tell you what it's going to do. It's quite good like that. So don't just do apply, auto approve unless you've done a plan or you know what the code's doing or you wrote the code yourself. Keep your modules up to date so that they've got patches. That's important, right? Even Terraform gets security patches, same as your operating systems. Keep things patched. Don't store your state locally. That's not so much a security thing as just if your laptop gets stolen, if your laptop blows up, then your Terraform state's gone, so put it remotely. But again, security. Don't modify the state manually, because you could really just stuff things up, and so on and so on. And it goes on a little bit there as well. And you can sign your things using manifests and what have you. But yeah, some good tips. Little bit of a sales pitch, but some good tips there for Terraform specifically, and for other ones that are just generally quite useful. So, least privilege doesn't apply just to Terraform. It applies to everything.
Yeah. So I think Terrascan is actually an open source tool, just by clicking on the link in the article, but also seems to be associated with Tenable. So I don't think it's too much of a sales pitch,
okay.
But just to be fair to those vendors. But yeah, as I say, we do have a bit of a policy around vendor pitches, and occasionally I'll let one slip through. But as John has highlighted, some pretty good tips in the article, nonetheless. So let's skip on to the second of our articles for this week, and this one is on the AWS Cloud Operations and Migrations blog, and it is entitled "Simplified Multi-Account Governance with AWS Organizations, All Features." So we're using organizations a lot, pretty much mandating it for all of our managed services customers now. So tell us a bit about this, John. AWS Organizations, and specifically AWS Organizations, All Features.
This is a vendor pitch too, isn't it? Are we allowing these?
Yes. But it's AWS news, so generally we allow all AWS vendor pitches through, and just to be clear, it's third-party vendors that we try and filter out.
I had to. I'm sorry, I had to. So we've spoken about organizations in the past. We've spoken about simple organization setups for SMBs, which is an Amazon acronym for small and medium businesses, because SME is something different, but it's what the government would call an SME, small and medium enterprises. What this is talking about is a specific part of the AWS Organizations product that allows you to set policies at the organization level. Now, there's 4 types, and I forget what they all are off the top of my head, but there's service control policies, there's resource policies, there's tag policies, and there's AI opt-out policies. There we go, that's awful. And what that means is you can apply these policies at the organization level, and that means to potentially every account in the organization, or you can apply them to some of the accounts at the organization at the account level, or you can group your accounts in what they call organizational units, so everything that's, say, non-prod or shared services or whatever, you can apply specific policies to everything that meets kind of that description. Yeah. So that's really useful. It means you can apply things like service control policies that say everything that's non-prod can't use anything bigger than a T3 medium or equivalent. You can't use anything bigger than that to keep kind of a handle on your costs. Or you don't have any resources in the Sao Paulo region, so we will block that region by applying an I am deny in the service control policy to say that if it's in that region, you can't do anything. So that, again, a way of keeping a handle on your costs, and it limits things like blast radius. If you do have a breach in one area or another, it means that people can't start spinning up things in regions that you're not using so that you wouldn't necessarily see it, because that's a common pattern. If someone's breached your account, they'll start putting resources where you don't look for them, because there's, I don't know how many regions, like 20, 25. So you'd put some there in an obscure region that people aren't using, so you just block them. It's great. It's really handy. The other all features that they talk about is consolidated billing. So what this means is every account has its own consumption. It gets its own bill. And by putting them in an organization, spit my tongue out, it passes those bills all the way up to the top level. So you get one invoice for the whole lot and you pay once. Now for SMBs, that's quite handy because they might not have a finance department. The finance department might be the CEO, like he's the guy, or maybe they have one accountant that deals with it. So they don't have the time, expertise, or inclination to be dealing with reconciling invoices from 10 different accounts when probably 8 of them only charge like 10 quid, $10 a month because they've got little bitty bits of resources in them. So that's really quite handy. And actually that applies to really big orgs as well, because you don't want to be reconciling 50 invoices. You want to get one invoice and then go through it and make sure it all makes sense. So it's all kind of in one place. And then from the technical people, from the FinOps people, it's quite handy because it means you can look at things like resource consumption in one place without having to kind of flip between all the various accounts that are doing things. You can sort of see it all in one area. I know we had an engagement to look at a very large account from a finance perspective, and that was really handy because we could just look at all the usage in one place. One bill. Yes, it was over 100 pages, but it wasn't, 50 of them where most of them are 1 or 2 pages and the rest of them are, enormous. It's just one very large bill and you can kind of cross off whole accounts. It's really quite easy. Worth noting that the features are not enabled by default when you create an organization. You create an org and they're not on. You have to go and turn them on. And when we create our Logi Zone landing zones, we go and turn them on, right? That's our default procedure. We enable the organization, flick the 4 buttons that turns all of these things on so that we can then start using them in the accounts, but they're not on by default. So you do have to do that.
So can we just go back to your guesstimate for how many AWS regions there are?
20, 25.
It's moved on, John. Things have moved on. There are now 31 geographic regions with 99 availability zones. Just thought I would have a quick Google while you were talking there, just to confirm that number, because not to prove you wrong, just because I didn't actually know the number and you were a little unsure. So for the listeners, as of today, my Google search has reliably informed me that there are 31. With plans announced for 15 more availability zones and 5 more AWS regions in Canada, Israel, Malaysia, New Zealand, and Thailand.
So that's a really key point, right? If you're sitting here in Northern Central Europe, you're probably not going to be running things in Canada. So you should turn Canada off. I don't mean turn the whole country off. Amazon doesn't have the power to do that. I mean, turn the region off in your account, right? Because if you're not going to be putting things there shouldn't be anything there. Turn it off.
Sorry, you just triggered something in my mind there with that, but we're not going to go there because that will, yeah. Have you seen the musical about the Mormons written by the South Park guys?
No, I think you're showing your age now.
Yeah. So no, it's a current thing, and my phone is ringing.
It's currently
ringing.
I
had disabled all of the audio, but apparently not. So there we go.
Slick. Well, it's the unlucky episode. If something was going to happen.
The Book of Mormon. There's a song in it.
Oh, I'm
called
familiar.
"Turn It Off."
I've not seen it.
Like a light switch, and that's what you triggered. So I'll play you the song later, and you'll get the association that my mind made when you were talking about turning off Canada. But I'm absolutely not about to burst into song on the podcast. I think we probably need a separate podcast for such content. Anyway, moving swiftly on before I do burst into song. The next article is from the AWS Compute blog. And it's about using AWS Lambda SnapStart with infrastructure as code and CI/CD pipelines. Easy for me to say. John, as we know, huge fan of serverless. So,
I mean, I am a serverless community builder. Got to get that.
You are indeed a serverless community builder. Pitching for that one. And so tell us about, I don't know what Lambda SnapStart is. So tell us about using Lambda SnapStart with infrastructure as code and CI/CD pipelines.
Okay, so start with a few definitions for this to then make sense, right? When you run Lambdas, you don't worry about the provisioning of the servers or the resources underneath it. You tell the service how much memory it should have. There's one dial, its memory and CPU are tied together. So if you need more CPU, you get more memory. If you need more memory, you get more CPU. They're kind of like one dial. You tell the service how much memory and associated CPU that function needs, and it kind of handles everything else. Part of this process, it will be spinning up a container, because they do run in containers. It will be spinning up a container, deploying your code to that container, and then sending the request to that container that's got your code in, and the response comes back and everybody's happy. Yeah. This is fine, but it takes a couple of seconds. Once you've done it the first time, it stays on the disk for a while. It stays live, active in the container on the server that they're running it on. It's serverless, but all that means is you're not running the server. There's still a server there. So it stays there on the server, able to serve requests for something like up to 10 minutes after the last request, so that if you've got a whole glut of requests come through, it will just stay there, and then the second and the third and the fourth responses are much faster. This is what's referred to as the cold start problem. Because the first one, it's the cold start, it's not there. It's much slower than the subsequent starts because there's something there. It's a hot start. It's already pre-warmed. Yeah. There's a number of ways historically that people have gotten around this cold start problem. One of them is have something make an arbitrary call, even if it fails, to your function every kind of 10 minutes just to keep something hot, keep it there. The other way is through provisioned concurrency, which is different from reserved concurrency. Reserved concurrency is saying that I must have 100 available, but this is punching my microphone there. I must have 100 available, but don't keep them hot. Provisioned concurrency is saying there must be one running at all times. That's quite expensive, but if you have microsecond latency requirements, that's the way you've historically done it. The other way that people have done is by using languages that start faster. So moving out of Java and using Python or Golang because they start much faster on the first instance. Like the Java cold start is about 5 seconds because it's got to deploy the whole JVM and all the rest of it. The Python cold start is about 2 seconds because it's Python. It's much faster to just get going. This is another attempt at solving that problem from AWS rather than from using kind of kludgy hacks. Lambda SnapStart is kind of AWS admitting that this is a problem, which is, I think, a first for them. And what it's doing is it's caching an encrypted snapshot of an initiated Lambda function. So you have to turn versions on. You can create an alias, but you don't have to. And then you have to tell it that it needs to, that SnapStart's a thing that you care about. Yeah. So you have to kind of enable SnapStart. It's just not just on because it does cost some money. Not a lot, but it does cost some money. And what this means is there's a cached snapshot of your function code on the servers whereby the Lambda will run. So it's kind of, it's not spinning up container, deploying code, running. It's just going up. It's just already there. So it's able to respond much, much faster. I don't know if they say how much faster in this article, but they certainly say that, it's go function ready versus update code, create environment, initiate code, blah, 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 and it keeps going. What this is kind of doing is this is pushing some of the delay time out of your runtime environment and into your deploy time environment, because your deployments, rather than just update function code's ready, it has to initialize the code and create the snapshot and then update the alias and so on. So it does mean that your CI/CD deployments are slower. So that is something to take account of. And that's why they talk about CI/CD here. But yeah, this is another way of solving that really quite annoying, somewhat intractable problem that there isn't really a good solution for. I've always been a fan of just writing languages that start quickly and make this a non-issue, because unless you have trading platforms, I could see this being a problem. But Common or Garden APIs, if the first time it runs it takes a second or two, and then the second time it runs it takes half a second, no one's really going to care. Not really, just so long as it's not obscene. So I see this as more useful for things like Java, where you've got to spool out the whole JVM the first time. So it kind of solves for that. Also worth saying that they have got examples for CloudFormation, AWS SAM, and Terraform. So it does also feel like AWS are starting to admit that more people use Terraform than they might like. But there we are. So yeah, definitely worth looking at if you have particular issues with cold starts.
And the answer to your question of how much faster is it, I found in another article, and it's up to 10 times faster than using Lambdas without SnapStart. So pretty considerable performance improvement.
Oh yeah, it's in the launch post, isn't it? Yeah, cold start in Java. That's what I've been saying as well, right? Because of all the JVM, the dependencies, and so on. Cold start of 6 seconds to 0.2 of a second. So yeah, it's like I say, it's a lot more useful for Java or other things that have lots of other environment runtime concerns than Python or JavaScript, which runs in Node. So they're much quicker to get going.
This article also did teach me a new AWS internal abbreviation. DevAx wasn't one I'd come across before, so I don't know if that's new, but it's new on me, and it's an abbreviation for developer acceleration.
Is that different from DevX, like developer experience, or DevRel, developer relations?
I guess it is aiming to speed up both the experience and the relations. They're looking to accelerate it.
Everyone likes an accelerated relation.
Yeah, absolutely. So might have to do a bit more Googling on DevAx, but DevAx was a new one on me. So there we go. Let's skip on to the next article then this week. And this one is from the AWS DevOps blog. And the title is Strategies to Optimize the Costs of Your Builds on AWS CodeBuild. So what can you tell us about optimizing costs on CodeBuild, John?
Oh, many things. Many things.
Well, we've only got about 7 minutes left of our allocated time. So let's just pick the highlights.
Okay, so CodeBuild, if you're not familiar, is AWS's managed CI/CD solution. We've spoken about it a little bit before. I'm more of a fan of things like GitHub and GitLab, but if you need to keep your code inside the AWS ecosystem, it's not half bad, right? You write it all in YAML, it's not that bad. You can run builds in CodeBuild. You can run pretty much anything you like. Arbitrary code can be run through CodeBuild. So if you really wanted to, you could probably build an ETL system in this if you were feeling a bit insane, but it could be done. In terms of optimizing your costs, it's kind of the same way you'd optimize your Lambda costs, because it's done per minute and for the size of the resource that you're paying for. So there's a crossover at which going for a larger resource doesn't reduce your costs because you're paying more for the resource, but the execution time isn't dropping commensurately, right? So you go from the smallest instance to a medium instance, your build time drops. Okay, cool. You go from a medium instance to a large instance, your build time doesn't drop as much because there's like a diminishing rate of returns. Same thing happens with kind of anything serverlessly or anything. There's a diminishing rate of returns, at which point it doesn't benefit you to go kind of up. So that's what they're talking about here. It's make sure that you're balancing your execution time with your resource costs so that you've got kind of that sweet spot. The next thing they talk about, and we like to talk about this, is looking at ARM and Graviton, because it is just cheaper to run. And if your resource is sort of IO heavy or compute heavy, then it's great. It's really good for that. ARM is really good at that. And then again, it talks about your build duration. So you need to make sure that, because you pay for the amount of time CodeBuild takes to pull your source. So if your Git repo is enormous, you will pay for your Git repo being enormous. So slim your repos down if you can. Do a slim checkout. Only check out like the top commit to make that process faster. build caching. This is more important for Docker than anything else. So you can kind of cache layers locally, which means it's not having to go off the Docker Hub or ECR to go and get them. So again, saving time. Don't run all your tests all of the time. I know, but you don't have to run your full regression suite against every feature branch. You probably only need to run it against integration because, again, you're going to pay for that. So it's just sensible use of the resources available to you, realistically.
Nice. So let's move on to our final article this week then, which is about Amazon Web Services transitioning to renewable energy sources. And we know from previous podcasts that you are a fan of renewable energy sources because you've got some solar panels on the roof at home. I know you've got some interesting viewpoints on Amazon's transition to renewable energy sources as well. So what are your thoughts on this one?
This is a funny one. It's technically every energy source is renewable over a long enough time period, but we talk about renewable in terms of, human scale, right? Because even coal's renewable, but you've just got to bury enough dead animals for it to turn into coal over hundreds of thousands of years. Everything's renewable eventually, but that as an aside. I see this as sort of an expansion of the previous point where, and this was a few episodes ago, possibly even last year, where AWS had bought a whole bunch of diesel generators because I think it's the Irish government had said that they will give priority to data center planning applications where the data centers have the ability to get off of the Irish grid when they're asked to, because I think there's more data centers than people in Ireland at this point, certainly in rural Ireland. I know that they use more power because Ireland is full of data centers. Okay, fine. But in order to prioritize getting power to people rather than machines, they put this priority on if you can get off the grid when we ask you to, then you're more likely to get approved. AWS dealt with this by buying a load of diesel generators, which is not very green. This seems to be a way to kind of redress the balance a little bit by using hydro-treated vegetable oil, so old chip fat, I would imagine, in Ireland. It's going to be old chip fat. Sorry, I know, massive stereotype, but most of the UK likes chips. So it's that sort of thing, whereby they can then run that through the diesel generator. It's just stuff that's going to get burnt off anyway, so it's kind of neither here nor there. Yes, it's not completely gas. It's not carbon neutral by any measure, but it's a lot better than diesel. So it's kind of redressing the balance a little bit of saying we've got all these diesel powered generators so we can get off your grid when you ask us to. Yeah, but that's really bad. Okay, so we'll run used veg oil through it instead. Oh, that's not so bad. So it's kind of, like I say, it's redressing that balance a little bit. And they have the commitment to, Amazon as a whole, rather than AWS, has the commitment to reach net zero carbon by 2040. So what I imagine this is doing is it's making the carbon that they are emitting a smaller number, so they have less to offset elsewhere. Because, if you're running a load of diesel, you've got a load of offset to deal with. If you're running veg oil, your offset's much lower. So it's going to be part of that as well. So yeah, it's an interesting one. Like I say, I feel it's a way of redressing concerns rather than something that they've kind of done altruistically. Of course, it's going to be cheaper than diesel because I don't know what diesel is in the UK now, but it's like what, £1.60 a litre, which for our American listeners is what's that, about $10 a gallon?
Oh, I don't even know the metric to imperial conversion, but I know it's come down a lot though.
It's 4.5 litres to a gallon in the UK, but US gallons are slightly different. And then you've got the currency exchange. So it's like $8 to $10 a gallon or something at the minute. So it's not cheap.
Thankfully, it is trending downwards though, because it was nearly £2 a litre when the war started. But
don't talk about the war.
Well, I think we're allowed to talk about that war, aren't we? It's just another war that we're not allowed to talk about. And that one was so long ago that we're probably allowed to talk about that one now.
Oh dear.
Anyway, that brings us neatly to the end of season 2, episode unlucky for some of LogiCast. So thank you for listening, and we'll be back next week. In fact, no, we won't be back next week.
No,
we will be back with another episode very soon. But both John and I are away next week, so we'll be back in a couple of weeks with episode 14 of LogiCast. So we'll see you again next time.